Welcome everyone. I know there is a lot of interest in the events that have recently unfolded and that are shortly going to unfold in California, and so I'm really just going to jump right into it. There are a number of concerns related to the incoming warm and strong atmospheric river storm due into northern and central California late Thursday into Friday. And the latest on this storm is that it truly does constitute a bona fide Pineapple Express type atmospheric river. Not all atmospheric river events are Pineapple Express type storms, and what this means in practical terms is that this particular atmospheric river has a trajectory of lots of water vapor moving quickly above your head in the form of what's known as integrated vapor transport, or IVT, which is the aggregate measure of all of that water moving quickly pushed by those winds in the atmosphere that is coming to California more or less directly from the subtropics near Hawaii, hence Pineapple Express. Not all Pineapple Express events involve moving moisture, or at least a large amount of moisture, directly from the tropics to the mid-latitudes. In other words, are those actual water molecules from the subtropics falling as rain in California? Often the answer is no. But in this case, Scripps did an interesting back trajectory analysis based on model data, and it does appear that a lot of the water that's about to fall in California really did originate in the ocean near the Hawaiian Islands. So this is a real and really classic Pineapple Express type atmospheric river event with a strong export of a subtropical moisture directly to California. And of course, one of the big concerns with that is this was going to be a pretty warm storm, immediately on the heels of what were historically cold storms, at least in terms of the ability for these moist air masses to drop a lot of snow at low elevations. That has been historically unusual, and even today there were ongoing reports of snow to unusually low elevations in Northern California. This is a pattern that's been bringing snow from anywhere from about 500 feet to 2,000 feet in elevation. Certainly points higher than that have been getting almost exclusively snow now for 10 or more days. So there is a lot of snow on the ground as low as 2,000 feet, and there is some snow on the ground locally lower than that still. That means that California really has a snowpack that is unusually widespread. So it's less unusual that the Sierra has a deep snowpack in March, although the current depth of that snowpack is exceptional, even at altitude. But then the more impressive thing is that there is actually a snowpack at all at 2,000 or 3,000 feet throughout almost all of Northern California. And so there is a lot of low elevation snow that is not extremely deep. We're talking like 6 to 26 inches or so, so in the sort of the less than a foot to a couple of feet range at these lower elevations, that is quite vulnerable to melting when multiple inches of rain fall on top of them with this atmospheric river event. So that's likely to be a concern up to about 4,000 feet in Northern California, and maybe up to more like 5,000 feet in Central California, including the Central and Southern Sierra Nevada. So there may be some significant snowmelt on top of the heavy rainfall from this storm, up to about 4,000 or 5,000 feet in the south, and maybe 3,000 or 4,000 feet in the north. And there is a substantial amount of snow on the ground in a lot of those places, whereas under normal conditions that snowpack might be somewhat minimal. Certainly in recent years, but this year there's quite a substantial snowpack. There's been much concern about the snow melting potential of this warm atmospheric river at higher elevations, where the snowpack is very deep, in some cases tens of feet deep in the high Sierra right now, including in populated places like South Lake Tahoe and a lot of towns in the high country as well, with very deep snowpacks. And it does not appear likely that this storm is going to melt very much of that very deep snowpack at high elevations. And there's a few reasons for this. First of all, are the basic thermodynamics of rain melting snow are quite different than a lot of folks might assume. And in fact, there's a lot of interesting science on this that's come out in the past couple of decades. The long story short is that it's actually really difficult to melt a deep snowpack a deep and particularly a cold snowpack. And right now the snowpack is both deep and cold at high elevations, meaning that the snow itself is at a temperature well below freezing. It's not slush right at 32 degrees, but the core of the snowpack is really well below freezing, as an ice block, as it were. It would take a tremendous amount of energy to melt that much snow, and generally much more than rain falling at 34, 35 degrees Fahrenheit, which is what the rain will likely be in the high elevations during this event, actually possesses relative to what you'd need to melt it. So what's likely to happen up at 5, 6, 7,000 feet and above is that there may well be rain on snow at those elevations, but the snowpack is going to absorb a lot of that water falling as rain. The snowpack literally has a lot of what's known as pore space, P-O-R-E space, and that means that the actual column of snow itself has a lot of space essentially to hold for additional liquid water to go in there and then refreeze in the snowpack itself, because the snowpack is well below freezing. So kind of like pouring some water into a freezer, if you will. If the water's really warm, you're going to melt a lot of the ice, but if the water is relatively small in volume compared to the amount of ice that's already in there, and the water is already close to freezing, it's actually all just going to freeze back up. That is the primary effect that we're going to see at very high elevations, and by very high, I guess I should say very high is maybe a bit of an overstatement. Really everywhere above about 5,000 feet in the south and 4,000 feet in the north, we're going to see the snowpack absorb most or all of this water. That doesn't mean it isn't going to cause problems at elevation. In fact, in some ways it's almost worse that it's absorbing all this water, given how many problems we're currently having with snow loading on structures. So we're hearing all about these roof collapses, these structural collapses, people's homes, public buildings, grocery stores. This is starting to become a significant hazard in the high country because of the extreme snowfalls that have occurred. Well, if rain falls on that snow but doesn't melt the snow, you can imagine what's going to happen is that existing snow actually becomes heavier. It doesn't necessarily become deeper, but the density increases, and so the weight on your roof increases. So this is why it's particularly important if you are able to get out there and remove as much snow from those rooftops as you can before the rain starts later tomorrow. So there still is about an 18 to 24-hour period before that storm will hit in the mountains to get out there and do so. So there is a real risk of structural stability issues and roof collapses, which of course, if a roof with a ton of snow on it collapses and somebody's inside, that is not a good situation. So that's going to be a real, fairly widespread problem because it's already happening, and this additional rain on snow will likely make that problem worse. Also, avalanche hazard will be high. I'm no expert in avalanches, but it's for some similar reason to the building snow loading problem. If that snowpack is absorbing a bunch of extra water without melting at high elevations, the top of the slab is going to become heavier. And so, of course, if you destabilize a snow layer by having some layers heavier than others, or denser than others, or better lubricated than others, as is the case if you add extra water to it, that's going to result in increased avalanche hazard potentially, including in some places that rarely see avalanches. So often the avalanche threat is confined mainly to places in the backcountry, but we've already seen a couple of avalanches in populated parts of the Tahoe Basin recently, and that actually could accelerate during any rain that occurs because it's really going to disrupt that already very large snowpack in places where people actually live. So avalanche hazard as well as the structural snow loading hazards are key. Now, I wanted to get that out of the way. There could also be some urban flooding up at higher elevations because, not because of huge amounts of snowmelt, but just because if there's any snowmelt, or even if just liquid water leaks out the bottom of the snowpack, and your storm drains and culverts are frozen and full of ice, then you're going to get ponding, which of course if it happens on your street or at your house, even though it's considered relatively minor urban flooding, it can still be damaging. So keep an eye out for that. The bigger concern with flooding is actually at lower to medium elevation. So we're talking about in Northern California, places below about 4,000 feet, in Central California, including the Southern Sierra, maybe up to 5,000 feet or so, still mainly centered below 4,000, but maybe a little bit higher as the rains, the atmospheric column will be a little bit warmer in the south. Below about 5,000 feet in the south and 4,000 feet in the north, there really will be significant melting of the snowpack, which is substantial at those elevations as heavy rain falls into it. But really, the main flood threat is coming from the fact that this storm is just going to bring a significant amount of rainfall in its own right, and that will all the rain that falls will become runoff, and that's going to be a challenge. And so there will be some additional runoff contribution from snowmelt at these sort of medium elevations, as I mentioned, between about 2,000 and 4,000 feet. But the main flood threat is coming from the regular old rain. It will be amped up a little bit by the snowmelt too in those regions that were mentioned. And that might mean that it's the foothills that see some of the worst small stream and river flooding, because that's where there's the maximal combination between heavy precipitation and probably the most intensive snowmelt, rather than at really high elevations. So the flood threat will likely peak in the foothills, and then there will be heavy rain, of course, in the coast ranges as well. So there will be flooding of creeks and smaller rivers everywhere from about the Santa Cruz Mountains southward into, I guess, Monterey County, SLO, San Luis Obispo, and places sort of in that Central California corridor from about the San Francisco Bay Area southward to the southern Sierra, so sort of in that swath of Central California from about the Bay Area southward, but north of the Central Coast. So this is probably not going to be a major flood event for, say, the Transverse Ranges or Santa Barbara, but north of there could be significant, and roughly about south of Mendocino County, which, of course, the exception being that places in the interior, places like Mendocino and Lake counties, even down at 1,500 feet, have a lot of snow on the ground. So even though the rainfall might not be especially extreme up there, there will be an unusual amount of snowmelt in those locations per inch of rainfall that could amplify flood concerns beyond what you would normally expect. And it's also worth noting there could be some structural snow loading issues even in these unusually low elevations, not because the snow loading will be as extreme as at Tahoe Basin, for example, but because the building codes at 1,500 or 2,000 feet in most of Northern California do not accommodate for significant snow loading at all. So the threshold that would cause significant damage is going to be lower. So if you have even a little bit of snow on your roof right now, and it doesn't melt immediately when it starts to rain, but instead absorbs some of that water, that snow is eventually going to melt during the storm, but in the early stages of the storm, it might actually increase that roof mass, combined mass of water plus snow initially. So that can be a problem there as well. It's difficult to be specific. I know I've been getting a lot of questions from people about specific rivers, specific streams, and addresses all day. I can't possibly go through all of those. But it is worth noting that the National Weather Service and the California-Nevada River Forecast Center provide official forecasts, including now publicly available ensemble river forecasts, which I think is great and important. And they're a little bit buried on their website, but you can find them. And they actually go out a full 10 days. So you can get ensemble river point forecasts 10 days out in the future. And those forecasts include both projected precipitation and projected snowmelt. So that should give at least a rough sense of the kinds of flooding or the locations that are at risk of flooding. So again, that's the California Nevada River Forecast Center, which is a branch of NOAA and works closely with the National Weather Service to produce these forecasts. These are the river projections that form the basis of official National Weather Service river flood warnings. The individual Weather Service offices are responsible for other types of flood warnings, like flash flood warnings and small stream flood warnings. But for the significant, certainly for the main stem rivers and also for some of the smaller rivers that have gauges and official forecast points, that is your go-to place. Right now, there are a number of rivers in Northern California that will likely be near or above flood stage by Sunday, either on Saturday or Sunday. Right now, I'm not seeing any indication of major river flooding on any of these rivers, which I think is in contrast to some of the headlines right now involving extreme or catastrophic flooding. Just to be really clear, I'm not seeing evidence of that, and I have conferred with folks at the state of California who do not anticipate. Just as a gut check, I wanted to make sure that I wasn't missing something important, and I think we're largely in agreement that flooding is likely, but severe or extreme flooding is not likely at this stage, certainly through early next week, so meaning not associated with this incoming Friday storm. No one can make any guarantees what happens after that, especially given that there is the potential for additional warm atmospheric rivers next week. And it's really just too early to be specific about those, how warm or how wet they might be. Right now, it does not appear that the follow-on atmospheric rivers will be as strong as the first one. So this first one will likely be formally classified as a strong atmospheric river. Not a weak to moderate one, but also not an extreme or exceptional one. So kind of right in the middle of the scale, trending more towards harmful effects than beneficial effects, because of course the weak atmospheric rivers can often produce beneficial effects in the form of bolstering snowpack and water supply. At the moment, though, we don't really need to bolster that snowpack more than we already have. It's essentially at record levels, and there's more concern about what's going to happen when it comes downhill. So we don't need that additional snowpack. A strong atmospheric river right now is probably going to cause more harm than benefits, but it also doesn't appear to be a worst case scenario. Folks are asking me, is this the arc storm? It is not the arc storm scenario. As significant as the impacts may be in some places, you could certainly foresee much worse scenarios. There's no indication that we're headed there in the near term. What this does suggest, though, and what this does emphasize, is that there are going to be ongoing concerns this autumn. My brain, it's been a kind of a frazzling week. For the rest of the spring, let's stick with this season. Really, for the rest of March and certainly through April and maybe through May as well, there is concern about the potential for larger and more severe widespread flooding later in the season. It is a conditional risk. It's not an explicit prediction, but it is an acknowledgement of the fact that when we have more than twice the average amount of snow water accumulated up in the mountains in some places, and most of that is not going to melt during this week's warm storm. In fact, I actually would argue that the overall snow water equivalent in California might actually increase a little bit on balance after the storm, because that existing cold, fluffy snowpack is actually going to absorb some of that water and it's going to refreeze, and so there may be even more water stored in that snowpack after these warm storms than before. It is all going to have to come downhill eventually. It is going to melt this spring into the early summer, and this is going to pose a conditional flood threat, particularly on the west slope, and also to the lesser extent on the eastern slopes of the Sierra Nevada. So both the drainages into the Great Basin and also drainages into the Sacramento and particularly the San Joaquin watersheds that are going to keep water and flood managers very busy and on their toes for the next few months. Again, right now, no indication of widespread severe flooding, either now or in the immediate future, but there is an elevated risk of that in general over the next few months because of this very large snowpack and the fact that it may simply, we may get lucky and it might melt gradually, but we don't know that that's going to be the case, and I don't think we can count on being lucky. So I think this is kind of a situation on some level of keeping the powder dry a bit. Since it's to say that this current event doesn't look like a disaster. There will be flooding. It could be significant or even serious locally, but probably not on a widespread basis. But most likely places for that to occur would probably be from about the southern half of the Santa Cruz Mountains southward into the Monterey County, and then eastward, essentially across that portion of the Central Valley, so the central and southern San Joaquin valleys, the central and southern Sierra west slope watersheds are going to be at the most risk of flooding in this immediate upcoming event, this warm atmospheric Pineapple Express type atmospheric river that arrives later tomorrow and continues into early Saturday. And the flooding right now does not appear to be severe on a widespread basis, but could be locally. And of course, things can always change. These are predictions. There's always the possibility that an atmospheric river can stall for longer than anticipated over a particular watershed. That's always, a concern, and it can sort of escalate impacts. One full atmospheric river category above the projected intensity level just based on stalling. It wouldn't happen everywhere, but it could happen locally. If the storm came in much warmer than expected, that would be another challenge. Although I will say that just looking at some of the data this afternoon, there's actually some evidence that these storms may be coming in a bit cooler than initially anticipated. And so, up above 6,000 feet, it is possible that a lot of this precipitation actually still falls as snow rather than rain, especially in the central and northern Sierra. The highest likelihood of places in high mountains seeing rain on snow would be in the southern Sierra, but in the central and northern Sierra in particular, it is possible that the changeover from snow to rain only occurs briefly. Essentially, the precipitation starts as snow, turns to rain for a little while, and then turns back into snow again towards the end of the storm. That would potentially mean that that the highest elevations would see all snow during this event. And it would also mean that there would be different kinds of travel impacts than you'd expect from rain on snow, and even more significant snow loading problems for structures at especially high elevations above 6,000 or 7,000 feet. So the good news is it also would mean that there would be less snowmelt from rain on snow than we would otherwise expect. So I wouldn't hang my hat on this yet. There are still some indications that snow levels could at least briefly get as high as 10,000 feet in the southern Sierra, but they could actually end up as low as 6,000 feet or 7,000 feet up in the northern and central Sierra. So that would be on the high end, but not that high. 10,000 feet would be very high, but that may not last very long. So we're just going to have to see how much cold air is retained in this system, how much of it mixes down to the surface. The challenge, I think, is that there's still a storm sequence yet to come, and we don't know how intense the subsequent follow-on atmospheric rivers may be next week. If they're weak to moderate and they're spaced out, we still may see a second flood peak, but it probably won't be as big as the one we're currently experiencing, or the one that we will experience on Friday into Saturday in most places. So that's the good news. The bad news is we don't yet know if that's actually going to be the case, and there are always a handful of model ensemble members that suggest much stronger atmospheric rivers than the average outcome, in which case, obviously, the flood forecast would be very different for next week if that came to fruition, and that is possible. It's not the most likely outcome at this point, but it is possible, and we don't know yet. So stay tuned next week. I'll probably be having another office hour at some point early next week to talk about that, especially if those higher end scenarios end up becoming more likely. The other thing to note is that even though the flood peaks don't look extremely high on any individual river system with this event, what's going to start to happen is we're going to see now elevated flows on a lot of major rivers for a very prolonged period of time. So not just for hours or even days, but very possibly more like days to weeks or longer. River flows may now stay pretty high on some of these systems for the next couple of months, with obviously higher peaks during wet periods or periods of snowmelt, but the baseline flows are going to be really high, and some of these rivers could stay above monitor stage or even close to flood stage for days to weeks at a time. That starts to become a bit of a concern with respect to the levees, especially in the Central Valley, because they are designed, of course, to accommodate flooding of some magnitude. But with persistently high river flows, you start to put pretty significant cumulative stresses, and it is one thing to have to handle a minor to moderate flood that lasts a day or two. It is a different story to have to deal with a minor quote-unquote minor flooding that persists for days to weeks, and that's the kind of flows that we might start seeing in some of California's major river systems starting later this month, sort of kicked off by this round of warm storms coming in. And so that is one scenario where you have weeks and weeks of high flows that start to put real stresses on the levees, and then say in late March or early April if we got a really strong atmospheric river then, or even just some moderate ones that are really warm back to back, or we get a really big early season heat wave, perhaps sort of the opposite weather type that could end up producing a similar downstream effect with significant snowmelt flooding. And this is just speculative, but if we have high flows for weeks leading up to it, and then there's a much bigger pulse in late March or early April or something like that for whatever reason, that is where we could start to see bigger problems, especially in the San Joaquin watershed, so all of the tributaries to the San Joaquin in the central and southern Sierra, and potentially in the Sacramento region as well, although I will note that the snowpack in the northern Sierra is not nearly as anomalously high as it is in the central and the southern Sierra. So that's thinking ahead a bit about what the long-term implications of what is likely to now be a prolonged high flow period will be. These high flows, it's worth noting, also have ecological benefits. It is good to have significant amounts of fresh water flowing out into the Delta and into San Francisco Bay for reasons as diverse as essentially flushing salt water out of the Delta, which is helpful, redepositing sediment. There will, of course, be lots of sediment traveling down the river system. These will be muddy waters, and this is one way to naturally redeposit sediment, both in the Delta and also in places in estuaries where they still exist around San Francisco Bay and in the Delta. This is certainly has some benefits to having a period or even a prolonged period of higher flows, as well as the risks that would come to the cumulative stresses on levees and things like that. I'm trying to think if there's anything else I haven't covered before I jump into the questions here. I think, just to reiterate, this will be a significant storm. I think it will be a very different storm for a lot of folks than the ones we experienced back in December through January. I don't think there's going to be as much drama associated with the storm itself, so there won't be as much extreme wind or thunder and lightning. There will be gusty winds. They're mostly going to be sort of under 50 miles an hour, which could still cause some problems with power outages and limbs down, because especially given all the stuff that's come before, trees have already been weakened by low elevation snowfall or recent windstorms. So that could be a problem, but it probably won't. We won't see the same level of wind damage we saw from some of the earlier season storms. The rainfall rates, like the amount that falls per hour, for example, may not be also as dramatic as we saw during some of the December and January storms, where there were some really intense hourly downpours, even in places like San Francisco during those storms. I don't necessarily think we're going to see that same kind of rainfall. Someone described the most common precipitation type during this event online as violent drizzle, and I think that's, in some places, that's going to be an accurate descriptor, particularly on the west slopes of mountains. Granted, you might end up getting anywhere from 5 to 10 inches of violent drizzle, so that's not trivial, but it does suggest that the phenomenology of the storm will be a little bit different than we experienced with these really intense bursts of precipitation December through January. The exception will be there is a possibility of some isolated thunderstorms embedded in this subtropical moisture plume, since it will be warm, moist, and buoyant. And so in those locations, of course, localized basis, you will see heavier instantaneous or hourly downpours embedded within the violent drizzle storm, if you will. So your mileage may vary there, and that places that do get those heavier intense bands may well be where there's a greater risk of flash flooding or small stream, urban, and river flooding than in other places. But I think there will be strongly orographic effects. I don't think San Francisco, Sacramento, San Jose are likely to see nearly as heavy rainfall in comparison to the nearby hills as they did in December and January, so it will be less of a equal opportunity precipitation producer, if you will. It will be more preferentially focused in the orographically favored mountain areas where the precipitation totals could be very high, locally in the double digits, but there might be a lot of rain shadowing in some places on the lee side, and sometimes the models underpredict the degree to which that's the case, so they slightly underpredict how much rain you might get in the mountains, but overpredict how much rain you might get everywhere else because they don't correctly represent the full extent of shadowing. So that is one possibility with the storm. As it's very warm and very moist, but not necessarily dynamically as intense, there isn't as much cold air support associated with it. The surface flow is not nearly as strong or as close to California as it was during many of the December through January storms. And the jet stream isn't in a position quite as favorable for upward vertical motion in the atmosphere in this case either. So it will be a different storm, but it will be a very high impact storm nonetheless. It's just going to be a different flavor of high impact weather than we've been used to recently. I think that's fair to say. All right, I think I'm going to take a pause to look at the questions that have come in thus far, because I do want to answer some. The first comment is regarding the fact that there is snow down close to 3,000 feet in the Santa Lucia Mountains which is all destined to melt soon. And it seems like it's snowed as many days as not over the past 3+ weeks. I think all of that is exactly correct. There is still snowpack above really probably even 2,500 feet in some parts of that mountain range. A lot of Monterey and San Benito counties, we don't think about them as mountainous areas, but there are places above 4,000 and 5,000 feet there. So especially in this pattern, which has been really favorable for cold, low elevation snow events, these are coastal mountains that are pretty tall in California, and they can get a lot of snow in these patterns, and they have indeed. There is a substantial snowpack, multiple feet of snowpack in some of these places, and that is a fair bit that's going to melt, because at that elevation, this is the kind of event that probably will melt most, if not all, of that snow, and that is going to contribute. So amazingly enough, there could even be some snowmelt that contributes to flooding along Highway 1, for example, in Monterey County. There will undoubtedly be landslides onto Highway 1. In fact, I think it'll be a small miracle if it doesn't wash out again somewhere particularly along the Monterey County coast, but perhaps somewhere else as well. Big Sur is probably going to have big problems with this particular storm. It would anyway, even if it was just the rain, but in this case there is amazingly actually some snowpack to melt up in the mountains above Big Sur, so that will just contribute to further runoff per inch of rain. I don't think it'll be a huge amount of additional runoff, but at this point, anything that's additional is going to be a problem. So it's, let's see here. Yeah, Kate from Big Sur points out that a lot of the snow is now gone from lower elevations. It's only up there on the highest peaks. So I think that's probably true. There's probably also some still sitting on the north-facing slopes that are harder to see from the west and from the coast. So it's probably, as I mentioned, not a huge additional increment in that part of the state. But again, it's a non-zero. It's a positive number, so it will add at least a little bit of runoff beyond what you'd expect from the precipitation alone. And if nothing else, that melting snow in those locations has kept the soil completely saturated. So it means that even if it hasn't been raining continuously, it's almost been as if it has been raining continuously in those places, because that snow melt is replenishing the soil moisture repeatedly. All right, here. Let's see. A question about whether there'll be major effects for Southern California from Ron. If you count the parts of the northern central coast as Southern California, that's always a fun conversation, then yes. Otherwise, probably not. The only exception will be because there is still major snow recovery efforts going on in the higher mountains of Southern California, particularly the San Bernardinos, but also some other places up above 5,000 and 6,000 feet. Even a little bit of warm rain on that snowpack is going to, as mentioned earlier, potentially cause additional snow loading issues. So it does not look like a heavy precipitation or real flood risk event in Southern California. It really does not appear to be that. So this will be a fairly unremarkable storm, except for folks in those extreme snow recovery areas where there's already problems still with accessibility and with structural collapses. Even a little bit of rain on that will potentially exacerbate the issues. So there could be some impacts. Otherwise, it's mainly a Northern California storm, and a little bit in the northern part of Southern California as well. There's a comment from Kent, who lives in Wilton. Elevation 0. That's always an important consideration, which borders on the Cumulative River. And on New Year's, I almost lost my house. The levee was very damaged and has not been repaired. What's it look like this time around? That is a significant consideration, and unfortunately, in that specific instance, I would be prepared for flooding again this time, particularly because the levee has not been prepared, and there does appear likely there will be at least minor flooding on the Cumulative River. And of course, minor flooding doesn't necessarily mean the impacts are minor. It just means that the actual height of the river is not as high as it would be during major flooding. If there's a hole in the levee and your house is downstream of it, it very well may mean that it's going to flood. So unfortunately, It does look like the Cosumnes will flood. It doesn't look like it's going to be a severe flood, although we kind of under-predicted the flooding back back on the New Year's event. Also, that may still have to do with the long-term hydrologic effects of the Caldor fire burn area, which burned a lot of the Cosumnes watershed at a pretty high intensity. That doesn't get factored into flood predictions, so to the extent that that amplifies runoff, it would result in higher than predicted runoff again, potentially. So that's, again, speculation. No one really has the numbers on that. But if you flooded a New Year's storm on the Cosumnes and that levee has not been prepared, then I would definitely expect that area to potentially be inundated again this time around. And unfortunately, more than once in the next couple of months. This storm could do it. The storms next week could do it again. And then perhaps with further snowmelt later in the season, it could happen yet again, because it won't take much. The Cosumnes is one of the least regulated rivers in the state, which has a lot of environmental benefits. But right now, in this somewhat precarious state where some of these levees have failed and where there's going to be a prolonged high flow period, that's going to be a concern on several similar rivers. Smaller rivers that nonetheless can produce major flooding and major problems when they do flood. Question from Dave about the recent upping of projected precipitation totals by an inch or two in the Santa Cruz Mountains. Yes, it does look like the potential rainfall in the Santa Cruz Mountains is a bit higher than it was a couple days ago, which of course somewhat increases the potential flood impacts. I still don't think that the flooding will be as bad as we saw during the peak flood events of December and January, but of course, as many folks have pointed out, the problem is now the cumulative issues with roads being washed out and mudslides and landslides and sinkholes and all of that. That kind of risk is cumulative. So although, say, like the San Lorenzo River probably won't peak as high as it did back in December or January, probably, although again that remains to be seen. If a thunderstorm sits right over the watershed there, then all bets are off. But even then, it is expected to flood. There'll be some flooding on the San Lorenzo and on similar rivers. And the bigger issue may be the progressively higher risk of earth movements, of landslides, mudslides, rock slides, all sorts of slides of solid earth, because the soils are saturated, the effects are cumulative, and a lot of the damage is compounding and hasn't been repaired yet from the earlier storm cycle. So that, I think, in the Santa Cruz Mountains could be really disruptive, and in similar places in the foothills, lots of landsliding, lots of mudslides are a real risk here, and I think that may in some cases may pose a greater risk than river and stream flooding, especially in places like the Santa Cruz Mountains with this event. Yeah, as Big Sur Kate points out, Big Sur also upgraded in the most recent model cycle. This really does seem to be where the atmospheric river will be most intense, so it won't be nearly as impressive up in northern California and even into the northern San Francisco Bay Area. Of course, it will still be a significant storm, but it really does look like from about Santa Cruz County southward to maybe the northern reaches of around San Luis Obispo, Atascadero, but probably not too much farther south than that. So this is once again another major atmospheric river that's going to focus right on the Central Coast and the Big Sur Coast in particular, and then extend inland to the Central Valley and the Southern Sierra foothills and mountains that are sort of in the same latitudinal band as that. Yeah, the Big Sur will be hit hard. Highway 1 is going to be a disaster zone, possibly literally. There's going to be a lot of landsliding. I will not be surprised if it washes out again. At least minor washouts and perhaps big ones too. This is that kind of pattern, unfortunately. A lot of questions about the Kern River and the Kings River, and honestly, I don't have specific insights into this. I'm not quite sure why I don't believe there are official forecast points on either of these rivers from the California Nevada River Forecast Center. That would be a question for them specifically. There is flood risk on those rivers, and the best advice I can give is that I would listen to local officials if they issue evacuation notices, to take them seriously, because this is the kind of pattern that could produce significant flooding. And I also would add that If there is going to be an area that sees worse than expected flooding from this event, I would think it would probably be that part of the state. It would be in the smaller rivers draining the southern Sierra Nevada that are part of the broader San Joaquin watershed. So I don't think that the bigger rivers in the Central Valley are going to see major flooding, and I'm not sure so much about the Kings River and the other rivers that drain that part of the state. That's going to be tricky, and I'm not quite sure the details on where to find better information for that. But the flows do look quite high. There is going to be a lot of snowmelt and a lot of rain in that part of the state in particular. So again, I think that may be from essentially from the western slope and the foothills and the southeastern portion of the valley there. That is most likely to be, if there is a place that sees more severe than currently projected impacts, it would probably be around there. Let's see here. Question about the Lake Tahoe snowline. It will probably rain for at least some time in Tahoe, but honestly, with the recent trends towards a slightly colder system, it is possible that the Tahoe area, especially as soon as you get right above lake level, even right up at like 6,000, 6,500 feet, it could end up being primarily snow. So be prepared for either, honestly, because you're going to be right on the razor's edge of rain versus snow, and it will make a pretty big difference which side you fall on it. Do be prepared for snow on both ends of the storm, both the beginning and the end anyway. The question is it mostly rain in the middle, or is it only a brief period of rain? That much is still not totally clear. The higher likelihood of very high elevation snow levels, up to 8 or 9 plus thousand feet, is in the southern Sierra, not the central and northern Sierra. And honestly, it's difficult to say, but I do think there may be some folks in the northern third of the state in particular they get a bit surprised by the fact that the snow level doesn't rise quite as much as it had been initially predicted. Whereas in Central California and in the Southern Sierra, it very well looks like that snow level is going to be way up at the peaks in a lot of cases. So it's a complex situation, and either way, there's going to be issues with snow loading and transportation over I-80, I-50. And in the Tahoe area and the Tahoe Basin generally. So it's going to be a mess no matter what. It's just sort of a question as exactly what type of mess is most likely at this point, I think. Let's see what else is going on here. Just going down the questions list here. Any idea on how to forecast the levels of the flooding on San Francisco Creek? That's near Palo Alto. I don't think there's an official forecast point. I'm not 100% sure about that. It's possible. Again, if you go to the California Nevada River Forecast Center website and you zoom in, so don't just use the big picture map, but actually zoom in on the, I guess it's right on the San Mateo County border maybe. Zoom in and see if it's there. That's the best bet. Otherwise, I don't have any official insights into that beyond that. It is a flashier watershed, so it's a fairly small watershed that responds to rainfall that's intense on sort of like 1 to 6 hourly time scale. So it can it's not so much of an issue to get heavy rain over a 24-hour period, but if it's concentrated into a few hours, that's the kind of smaller watershed that is hydrologically known as a flashy watershed, fast responding to precipitation. So really, the big concern is if you get like a really heavy 1 hour or 2 hour downpour, that would be the kind of thing that would send the creeks like the San Francisco Creek to high levels. So whether or not we see that in this case remains to be seen, but I'm not necessarily seeing, I think the likelihood may be lower on some of these flashier systems with this event than during the December and January events for reasons previously mentioned. Another question about, for some reason CNN ran an article talking about 2 weeks of flooding and mentioned Marin County specifically. Is Marin County actually in danger of extreme flooding, as CNN claims? During this event, no, I don't think so. This is not an event that would particularly concern me about Marin. There is a risk of flooding and land mass movements like mudslides and stuff, but this storm looks like it's primarily focused south of Marin County, and also Of course, there's no snowpack. I don't know, maybe there's a dusting left on top of Mount Tam, but there's no meaningful snow to speak of in Marin County that could melt, and this is not necessarily going to be an especially extreme precipitation event for Marin in particular. It is March. Marin County is a wet place, as are many places in Northern California this time of year, so it takes a lot to produce severe flooding in these places. I don't necessarily think that it's going to happen there, with, again, the caveat that if any one place gets stuck under one of these subtropical thunderstorms, which will be scattered around, they won't be widespread, but they'll be isolated, the picture could change quickly because soils are saturated, and it would really only take an hour or two of a really intense downpour stalled out somewhere to cause flashier creeks and streams in these kinds of places to respond rapidly. So I can't rule it out, but I also wouldn't suggest it's a likely hot spot for flooding in this particular pattern. Yeah, comment from Ron about how Ron is in crest line at about 46,000 feet. That would be pretty high. 4,600 feet in elevation, and still has 50 to 60 inches of snow on the ground, with a lot more on the ground as you go up in elevation in the San Bernardino Mountains. Yeah, it's a lot of snow. And if there were to be a warm atmospheric river aimed at Southern California squarely, this would be a pretty big problem. In this case, it doesn't look like there's going to be that much water in Southern California, although there will be some, and there probably will be some snowmelt. So I don't foresee a dire flood situation, but again, from a snow loading perspective and a disaster snow emergency response perspective, it is going to cause some challenges. Let's see here. I'm going to go to the end and then work my way backwards a little bit again. A question from Michael Hall about whether there are any reservoirs that are lacking remaining capacity for this immediate event. And I actually spoke with folks at the Department of Water Resources today, and really the story is that the far northern California reservoirs, so talking about Shasta and Oroville, have a good amount of room, generally speaking, although they will start to have less headroom as this event goes on. The reservoirs on the Sierra Western slopes from the central and southern Sierra have less headroom and are... So there probably will be some reservoirs that enter flood control mode, essentially flood operations, where the primary management objective is to reduce the risk of downstream flooding rather than to conserve water for the dry season to come. That switchover point hasn't happened yet on most of the reservoirs, but it could happen on new reservoirs as soon as this weekend, as far as I hear. So the Oroville spillway, the new one, the rebuilt one, following the events of 2017, might start spilling within the next week, as will the spillways on probably a lot of other significant dams in California. So that's not a problem per se. The spillways are designed to release water during big storm events to maintain that headroom, to maintain that safety margin. But it does suggest that the inflows are now big enough and that the reservoir levels are now high enough that they don't want any more water stored in them for safety reasons, and so they're going to start to release more of that water, I think, from a number of these reservoirs as flood control operations begin. This had long been expected by folks at various entities that operate these dams, given how much snow has accumulated and given how much rain fell back in December and January. So it was already obvious that eventually we were going to enter flood control operations on these structures at some point this season, this spring. We are now in March, and some of these reservoirs may be in flood control mode for a fairly long period of time, or it may oscillate back and forth as the amount of precipitation and runoff waxes and wanes. Most of the reservoirs in California that have the ability to engage in what's known as forecast-informed operations, so they release, they either reserve or release water on the basis of projected storms rather than just observed storms. Those plans are generally fully in effect right now, so reservoirs that participate in the forecast-informed operation programs are currently operating under those guidelines, which is great because it gives both more flexibility from storing as much water as we possibly can without compromising safety margins. And so when you see a forecast like this, forecast-informed operations would imply that, okay, we actually do need to start releasing some water in advance because we can see what's coming and it's a lot of water. And we don't know exactly how much water because we can't predict what's going to happen 10 or 14 days from now with any certainty. So it would be wise to start releasing some of that water now, and that's of course exactly what's happening at these reservoirs. Brad remarks that Oroville is expected to start spilling on Friday, which makes sense to me. That doesn't sound too surprising based on what I've heard. I wasn't quite sure exactly when, but that makes sense. Stu remarks that the California Nevada River Forecast Center does have a forecast point for San Francisco Creek, so that is absolutely where I'd suggest that you go for your information on that one. Let's see here. A comment from Michael that it sounds like we're in good shape for the flood control system from a reservoir perspective. I would say that we are from a reservoir perspective for now. That could change later this season. As I mentioned, there's a lot of water up there, and depending on the sequence of events that unfolds, is it just relentlessly wet for the next month or so? I don't necessarily have any reason to think that's likely, but it's possible. Then we could run into some bigger problems. Do we get it? Does the opposite thing happen? Does the storm train suddenly shut off at the end of March and we get 70, 80, 90 degree heat wave in early April? No particular reason to think that's actually going to happen, but it could happen, and that would cause similar issues where we might start to run into bigger problems. But at this point, that's speculative. But I will point out that there are some years when that's not a risk, right? And some of these years where we've had extremely low snowpacks, that just wasn't something that was possible in the spring because there just wasn't enough snowpack to pose that threat, at least conditionally. This year we do have that kind of snowpack, and so it's going to be something that keeps water folks on alert really through the end of the season. And so we got a couple more months of keeping a close eye on these things for sure. A question, a somewhat technical question that I'll get to because we have a few more minutes before I sign off for the evening, from Stu about the notion of advected latent heat. In other words, the direct condensation of saturated air onto snow and the release of the heat of vaporization as a major source of energy when it comes to essentially rain on snow events and the potential for warm storms to melt snowpack. There is as I mentioned in the beginning of this conversation, there is a lot of interesting science on this. And it turns out it's often not the raindrops, the water itself, that does all that much snow melting when rain does fall on snow. As I mentioned, often it actually ends up getting absorbed by the snowpack. But instead, what is actually happening is it's the air mass itself. The fact that if it is raining, by virtue of the fact that it's raining, you have both a saturated and a relatively warm, at least relative to the freezing point, air above the snowpack. And so moist, warm air has a lot of capacity to melt snow from the surface down. And so there can be a lot of energy exchange essentially between the snow surface and this relatively warm, moist atmosphere. And so, as is mentioned, there can be direct condensation of moisture from that saturated air onto the snow surface. And of course, there is energy released when condensation happens. The latent energy stored in the phase change, essentially that's the result of the phase change of water. And so, yes, that is a major reason why when we do see warm rain events, why there can be snow melt. So again, it's not so much that like the warm raindrops fall into the snow and they instantaneously melt, but it's more that the exchange of energy from the air mass, which is inherently above freezing if it's raining, and also moist, really starts the surface of the snow melting pretty quickly. That's the thing, and that's the reason why deep, cold snowpacks don't have the same problem, is that even if you get a little bit of surface snow melting, which you probably would, that surface snow is just melting into the much deeper, colder snow layer below it and likely refreezing. But if you only have a shallow snow layer, say 6 or 12 inches deep, as is the case across the lower and middle elevation portions of California right now, then if you get surface snow melting, that water may melt all the way to the bottom of the snow column because it's only 6 or 12 inches down, and there's the surface, essentially the ratio of the surface of that snow to the depth of the snow is a lot higher in the case of a shallow snowpack than a deep snowpack. And so for that reason as well, it's much easier to melt a shallow snowpack because there's a lot of surface area and not a lot of volume. In the case of a deep snowpack, there's a limited amount of surface area relative to the very large volume. And so the interface for that exchange of energy across the surface of the snow, between the surface of the snow and the atmosphere, is limited in the case of a deep snowpack, but it is quite high in the case of a shallow snowpack. So I think sometimes it turns out, and this is something that I learned, not that long ago, to be quite honest, since I'm neither a hydrologist nor a snow scientist. It really is that sometimes our fear of rain on snow events is a little bit overblown, because it's not really the rain on snow that causes many of the problems. It's usually just the plain old really heavy precipitation that's falling as liquid rather than solid. So even if it isn't melting the snow, if it's raining, there's a good chance that it's running off rather than accumulating, and so you just get that much more instantaneous runoff because that much more of the precipitation is falling already as a liquid to begin with, rather than snow, which is solid and accumulating and melting at some later point. All right, here we're right at the hour, and so I think I'm gonna call it an evening. It's been kind of a long week, and it's going to be another long week to come, so I'll probably have another one. Please do feel free to check out my most recent Weather West blog post. Although, inevitably, as soon as I write those, they're already a little bit out of date. I don't think there's any major things that have changed, but I do think that, some things have changed. The storm totals have increased a little bit in some areas and decreased in other areas, and overall, the central and northern Sierra might not see snow levels quite as high as before, which I guess is good news from a flood perspective, but not so good news from a snow loading perspective and a transportation perspective. I really think the focal point of impacts is going to be Monterey, sort of that swath from Santa Cruz down to Monterey County, and then sort of east and northeastward from there into the southern Sierra Nevada, and then all the watersheds that drain those areas, I think, are going to be the hardest hit during this event. All right, well, I'll still be on Twitter, and then depending on how events evolve, I'll have more office hours in the near future. So thanks again for watching.